5.9 Cloud Security for Hyper-V is the agentless security and compliance solution built specifically for Microsoft Hyper-V. 5.9 Cloud Security consists of three main components: Management Service, which acts as a management server; Management Console for 5.9 Cloud Security centralized management; and Host Management Service, which is installed on each Hyper-V host intended for protection. This makes 5.9 Cloud Security easy to install and maintain by administrators of any level. Let's have a brief look at the way it works on the Hyper-V level. So if you go to Virtual Switch Manager on the Hyper-V Management Console, you can see the 5.9 Virtual Firewall extension integrated into the Virtual Switch. The current version is version 4, and this is the one which allows 5.9 Cloud Security to completely control traffic inside the virtual network. So let's have a look at the Management Console, and as you can see, the virtual machines were not monitored with our firewall protection. So therefore, at this stage, they can access each other with no problems at all. So these are two virtual machines. One of them is Windows client, and the second one is CentOS, a virtual machine with Apache web server installed. So while virtual machines are not being monitored, you can see that Windows client can easily access the CentOS VM through the web interface, as it is a web server, and it can also ping the virtual machine. So ping requests go through and they work. So let's have a brief look at the rules enabled. So right now for all VMs there is a setup which has ISMP traffic allowed and RP traffic allowed on the network. So we enable monitoring on Windows client and CentOS VMs, and you can immediately see what happens throughout this way. I just remind you that ISMP traffic is allowed, RP traffic is allowed, but there is no allow rule for the virtual machine to receive the HTTP traffic. This means you can completely isolate virtual machines from each other, and they'll be entitled only to the traffic you allow them to use and to communicate with each other. So right now, let's have a brief look at the web service group, which has HTTP rule allowed and ISMP traffic blocked. So we'll add the CentOS virtual machine to the web service security group, and it should immediately reduce the rules assigned in that web service security group. So right now you see that HTTP allow and ISMP block are effective for the CentOS virtual machine. So let's go back to our test system. So you see that Windows client can easily access the web server now, but ping requests immediately stopped working. So I remind you that we just allowed the HTTP traffic to the CentOS virtual machine by adding it to the web service security group, and we blocked the ISMP traffic. Security groups allow to conveniently set up firewall rules for multiple virtual machines playing the same role, and also allow to conveniently set up a group of virtual servers. So what we are looking at right now, we are looking at the Windows Client 2014 virtual machine, and that virtual machine doesn't have the HTTP rule allowed. So we are going to create a web clients security group, and this group will include the HTTP outbound allow rule, and we'll assign that rule to a group of virtual machines which play the client's role. So as you see, we are adding the Windows Client and Windows Client 2014 to web clients group, and the Windows client already had HTTP allow rule, but on the virtual machine level, and right now we are adding both of these virtual machines to web client security group, so therefore both of them received the HTTP outbound allow rule. As you see, we refresh the page on Windows Client 2014 virtual machine, and it can easily see the web server on the CentOS virtual machine. What we are going to do next, we are going to set up this specific requirement for web service security group to allow its communication only with the security group of web clients. So the web server security group right now is allowed to receive the HTTP traffic for web client security group members only. As you remember, Windows Client Virtual Machine has the HTTP rule allowed on the virtual machine level, but right now we just removed it from the security group, which was called web clients. Right now, Windows Client 2014, which is still a member of this web client security group, can still access the web server, but when we start to refresh the page on Windows Client Virtual Machine, which was just removed from web clients security group, you see the page becomes inaccessible. So page cannot be displayed. Let's add it back to security group to demonstrate that this is the actual reason. So we add it back to web clients, press OK. We go back to the virtual machine, and here where the magic happens. So the virtual machine can see the web server again. Everything is done in a few convenient steps, and this allows you to do the management scenarios very fast. Right now, let's have a look at the intrusion detection system capabilities. To do that, we'll run a set of commands, exploits emulation commands, and we'll set some strange packets to the CentOS virtual machine web server. I'm typing in the IP address for that virtual machine and press start. So the emulation goes on, and it just takes a few seconds. Press OK, and if we go back to the management console to check the status of the intrusion detection system. So if you have a look at the intrusion detection system tab and check the log, you'll see that the CentOS System Lab virtual machine just received a certain number of strange requests, and IDS just detected all of this for us. This IDS engine uses the snort engine, and it allows you to block the detections via just few clicks, and you can create firewall rule out of the intrusion detection line. So right now I'm going to show you the multi-tenant functionality, which is a very important part of the product. We'll create a tenant and which will be entitled to monitor and modify the firewall rules only for certain virtual machines. So let's pick up Red Hat and 2 Windows clients, and I'll pick up the user from Active Directory, and we'll assign security administrator and auditor user role to that user. So you see that this user just created as a tenant client will be using and entitled to manage only the virtual machines that I specified. So let's run the management console as a different user, and I'll type in the credentials of the user I just specified as the tenant. Just a few seconds to do that, and we'll see what that user is going to see in his management console. So management console can clearly show you that this user has only the virtual machines we allowed him to view, to monitor, and to manage the rules on. The all VMs rules are also visible for that user, so he's aware of what kind of firewall rules are set for his virtual machine. Let's enable the HTTP allow rule for Red Hat virtual machine, and we're going back to the management console and using it as the administrator, and we should be able to see that rule modified for the virtual machine by the tenant. Let's have a look. So Red Hat Enterprise Linux HTTP rule is here. So tenant just created the rule for himself, and of course administrator is able to see that. So the multi-tenant functionality is a very important part of the product, and it allows to create the multi-tenant infrastructures. We are switching to antivirus functionality, and right now I'm showing you that we just had the log on the screen, and that was a previous scan. We just took a few actual seconds for the virtual machine full system antivirus scan. What I'm doing now, I'm mounting the ISO file with viruses inside to copy them into the client virtual machine to show you the antivirus functionality. So let's go inside the virtual machine. We just mounted the ISO file inside that, and right now we are able to copy the viruses on the desktop to show how the antivirus functionality actually works, and how do we detect the viruses sitting on the virtual machine. So there are quite a few viruses in here, so let's move them to the desktop, and this will be our test viruses for the antivirus scenario. The Five9 agentless antivirus doesn't need any agent installed on the virtual machine to perform full system scheduled scans. So this means no virtual machine performance is ever used. The agentless approach is very effective for the virtual infrastructure, and this is also accompanied with the change block tracking driver, which allows Five9 agentless antivirus to perform incremental scans rather than running the full system scans over and over again. The antivirus uses the change block tracking driver to detect all the changed blocks since the last full system scan, and uses that information to perform the scanning process. We are able to scan only the difference between the full system scan last time and the new antivirus scanning process. This actually takes the resources used and the time used for full system antivirus scanning on virtual machines to very low level. Five9 Security for Hyper-V solution is also available as the plugin to Virtual Machine Manager component of System Center. So this makes the security management for System Center administrator a very easy process, and the one which is using the functionality of Five9 Security for Hyper-V product. So let's have a brief look to the environment which has a virtual machine manager installed with Five9 plugin in there, and we'll have a brief look at the way it works when it's a part of virtual machine manager. We'll use two virtual machines, and one of them will send pin packets to 4222 IP address, and we'll create the block rule for ISMP traffic instead of the predecessor allow rule, and we'll see what happens when we do that using the plugin for System Center Virtual Machine Manager. This was Five9 Cloud Security product. Thank you for your attention. We are looking forward to cooperating with you and to build the better products for Hyper-V ecosystem to support big Hyper-V projects over the entire world. Thank you.